Well, I have an issue. I was trying to make a video for Super Nintendo and other things, and I go to plug my Super Nintendo in, the Super Nintendo Junior here, and it did not display anything at all when I turned the power on. Now, at first I was thinking, well, maybe it's because, just getting some weird signals, or maybe the game isn't registering. But then I tried the original Snes Super Nintendo from my childhood, and that one will not work at all either. So is it the console or is it the power supply? And it appears that it is the power supply. This is the original power supply for the Super Nintendo, and it is center pin negative. So if we plug this in, grab Steve in here, turn it on, 20 volts, the center pin should be negative, so the black probe goes in here, make sure it's actually connecting, red probe goes here, and we are getting absolutely nothing on here. Not a volt. And we'll even make sure, 100%, not a single solitary volt. Now, before we continue, I am not a professional nor an expert. I am teaching myself how to repair electronics, so don't consider this video a tutorial, but rather a learning experience as we go along. So, how do we get into this power supply? Well, in Nintendo's spiteful decision, they decided, well, let's go ahead and throw some weird, funky screws in here. These are actually oblong. They're not 3.8 millimeter. They're not 4.5 millimeter. They are oblong. They're very strange. And I've already managed to unscrew this one. And you can see that it is oblong in shape. Now, how do we get these open? Technically, you're supposed to use a spanner bit. I don't have that kind of budgetary means right now, so I went ahead and cavemanned it up and just grinded a flathead screwdriver, and it fits reasonably bad. But it worked. So we're actually okay. Probably need to widen this out just a teeny bit more, but that's okay. It worked, we're fine. So we got this one, now we got to get this one unscrewed, which will show us the innards of this thing. Okay, we need to widen this. All right, everybody, engage their safety squints. Just a little bit more. Let's try it again. Still a little bit more. Let's try that. Might work better. Might need to be a little bit more. There we go. It's got enough grip. There we go. Now this should come out like this. And you know what? That almost looks like a bad solder joint. Does it not? Or am I wrong? Right there, maybe. It's possible. It might be fine. Okay, so we're gonna go ahead and push this. I think this goes straight up. Right there. All right. There we go. Now, can we touch this transformer? I don't know. We didn't die. We're good. There we go. We got these resistors and these diodes. Okay, well, let's check this capacitor. Let's see if it has any voltage at all on it. So, was this positive? We got 13 volts, and if we switch this... Okay, so this side is positive and this side's negative. We got 13 volts stored up on this capacitor. Interesting. Does it show any voltage in here? 13 volts. Okay. Well, that's not good, is it? So then is it actually the consoles? Is it the plug itself? Let me try this, because we're getting 13 volts here. So in theory, we should have 13 volts coming off here, right? I think that makes sense. You know what? Here's a brilliant idea. What if we put the multimeter into continuity mode and see what that does? So right now, this should be ground, right? Yes. So this should come all the way up to this center pin in here. Let's see. So if we get a beep on this center pin, that means we have a continuity from point A to point B. But if we don't get a beep, okay, so we get a beep for ground. Do we have a beep for the positive side? We do not. Aha! Interesting. So if I'm thinking about this correctly, if I'm thinking about this right, we've got continuity from ground to ground. as long as this should happen, right? There should be... Wonder if we flip this over and we test from the prong just to rule everything out. So I don't know which prong is supposed to be ground. Let's put this here. It's a little loose. Interesting. Probably not nothing though. Is this continuity? No. Continuity on here? No. So we are having a disruption between positive in this cable into here. I was expecting it to be the capacitor, but what we need to find out is there anywhere... Okay, do we have continuity from here to here? We do, right? So that means this from here to here is good. What about from here to here? Okay. And this all goes somehow the same area. Wait, does that show good? Huh. Should we have continuity from this pin here to ground? Does that make sense? I don't know. I guess that makes sense. I got hope. So, if we snip this cable off, like somewhere here maybe like right here, and then we can test the wire. The problem is we don't want the break or anything to be in this area. If there is a break, we want the break to be somewhere in this area, because that would be hard pressed to find a replacement for this. So let me think about this real quick. Look some information up and see if I'm going down the right path. So I've had a little bit of a look online, and I know I was watching another video earlier today before I even started recording where this guy was repairing one of these capacitors, or replacing them rather. He actually replaced the diodes as well. So that might be a possibility. Now, one thing I really don't understand is we have continuity between ground and positive. So we have continuity here and here. That does not make sense to me. Does that make sense to you guys? Because like I said, I'm still learning. So I don't think positive and ground should be connected. Now, one thing that possibly could be happening is we have these diodes here, these little black, little bead things looking things right here. And these are, I forget the type of diodes they are, but they're diodes. And I did look up something that said you put your multimeter into diode mode and then you measure between here, this is the negative side and this is the positive side, and you get a measurement and it's supposed to drop voltage. Right now it says 3 and it's dropping negatively, and now it's charging, so it's gone to positive, and now it's going down, so I'm not sure what I'm doing. And then it's supposed to be open line if we put it this way. And it's basically doing the exact same thing, whether the black probe is on the right or the red probe is on the right. And then for this one, it's basically doing the same thing. In fact, it's doing the same thing exactly. Neither one is open line, so that could be a problem. Now, again, one thing I saw online was to take these out of circuit and then measure them, so that's a possibility. This capacitor looks like it's actually okay, but we can test it out too, I think. Let's try that. We're going to try this. Now, I have not used this thing successfully yet, so hopefully we can figure this out. This is called an ESR meter, and it's supposed to calculate if the capacitor is good, and it will work in circuit. So we've got a 16 volt, 4,700 nanofarad, or what are these things? Microfarad, not nanofarad. Capacitor, and so 47 UF, 16 volts. So if we look at this, 4700 and 16 volts should be 0.2. Does that make sense? 0.2, so 16 volt, 0.2, 47, yeah. So think if it's above that, it's bad, I think. Let's try it. So we gotta get our probes. Got our probes here. Black goes to black, and red goes to red. Now we also have to zero this thing out apparently. So let's turn it on. Oh, it's not working. Is this battery up? Let's not check the ESR. Well, unfortunately, there is rust. That's depressing. Well, we'll figure that out some other time. In the meantime, let's go ahead and desolder that those diodes, and see if they were, still do the same thing out of circuit. And if we have continuity on there, then that's the problem. Or if we don't have continuity between positive and negative, then that would probably be the reason, right? That makes sense. Okay, let's go. All right, let's get these diodes out of here. We're just going to apply some flux already and suck the solder out of these holes. The person that put these in here originally bent the legs, so it's a little hard to get them out. But after some force and some heat, voila. And this other side was a bit more tricky. I don't know what was going on. Probably some oxidation on the tip was hurting us a little bit. But after some trying and some wiggling and maneuvering, we eventually did get them out. Okay, here we go. So, got these diodes desoldered, and one of them was really difficult. It's like when they plugged them into the holes, they bent them, so that was really difficult. But we got it done. Now, I did test out real quick while we were out with the spare multimeter, and continuity-wise, we had something interesting happen. Never mind. I swear when I was out in the garage, I did that and it did not have a continuity. Is that right? Should we have continuity on the 2 prongs here? Does that make sense? Do we have a short somewhere? I don't think these things used a fuse on this. There's a fuse in the Super Nintendo itself. Or is it? You know what? Here, let me think about this. So, as far as I know, and I could be totally wrong, but I believe a transformer is one big coil, so basically one big winding. So we're picking up the winding of the transformer by doing this? Does that make sense? Is that stupid? I don't know. Feel free to leave your comments and educations in the comment section below. So, do we still have continuity between these 2 points? No? Interesting. Is it because the flux is... Okay, yeah, it was just the flux. Okay, we'll have continuity everywhere again, so I don't know what that deal is. Well, let's check these diodes in this box then, because I thought we were onto something there, but maybe not. Alright, let's see. Do we get readings like this? Yep, and it goes down, and it keeps going down. It hovers around 0.408. Is that right? I don't know. Let's try flipping this. And does it go open line? Oh my goodness. We are staying at 1. Does that mean that that's open line? It's not changing if I take it or put it on there. Don't put it on there. Nothing. Well, is that a good thing? I don't know. Sometimes I feel like I wish I was live streaming so I could have somebody tell me, you're not doing this right, or do it this way. So, again, gray band on the right, and positive to there, and nothing. Okay, so we flip this, then this should get a reading, right? Oh my gosh, please. Need alligator clips so bad. There we go, we almost got it, okay. Goes to 0.71. Okay, and then if we reverse it, it should be nothing. Does that mean that these are working? Is it possible we just have a cold solder joint on this thing? Is it possible that the capacitor is bad? Capacitors can break down connectivity, right? What if we did this? Put this here. I suppose that's connected. Still not sure what we're missing. It's possible that the capacitor is bad. I suppose it's possible that this resistor could be bad too. Let's see, FA624. Is that from the brand of manufacturing, perhaps? Let me see. Does this resistor have continuity? No. I assume this is a resistor. These can be capacitors. I don't have any markings. I'm going to assume it's a resistor. Does it have continuity this way? What am I doing? I have no idea. Nothing. So, like, I don't know. I'm not sure what's going on with this. Is it still possible we're having a short in the cable? Shouldn't this be connected somehow to this? I guess not. Definitely don't understand what we're missing yet. Maybe another search on Google will help or something else. All right, I think I was starting to go down a rabbit hole with that resistor. I don't think that's our problem. I think we do have an issue with this cable because I was looking at another video and the gentleman replaced the cable and that will solve the issue with not getting anything here. So, well, let's go with the nuclear option, I guess. What could possibly go wrong? Let's cut the cable. We'll cut it here. Let me think. Yeah, I'll cut it here. And we'll strip this back. And we'll strip these. Oh, look at that. That was probably our problem from the get-go, wasn't it? Right in there. Unless we got that stripped from using this on it. I should have cut this a little bit better. We'll do it this later. We're just going to cut this off here. And now let's go ahead and strip this back. Alright. And let's strip this one back. I promise I know what I'm doing. Maybe. So now we've got probably negative here and probably positive here. So let's go ahead and grab our multimeter. Set it to continuity. And let's see if we get a reading from these wires that are exposed now. We should get a reading from the sheathing to one of these wires. So let's see if we do. And we do. Okay, and then inside here should connect to the other one. Yep. Okay, so we have continuity from the sheathing to this area. So with that, I should have done this better, but that's okay. We'll deal with this. So what we're going to do is we're going to trim this back just a little bit more. And we're going to assume that we had this issue here because this was already frayed. I think that makes sense, right? Actually, we could look at that too and see if we have continuity from this to there. We don't. So I think we know what we're doing. So now what I'm going to do is... Oh, I screwed this one up too, didn't I? Oh, shoot. I should have... Okay, maybe we can stick something through this and push it through all the way. And we can reuse this stress relief on this part. We'll strip this back a little bit more. We'll desolder here. And then we'll connect this up to this. And then that should possibly fix the issue. We're going to have to resolder these... diodes back too, see if that will work, and then hopefully we have a working power supply. I feel a little silly going through this and pulling off these things. I was on the right track, I think. I think we're on the right track now. We'll see. All right, let's get these diodes put back in. Add some flux to the board. Use some braid to suck up all the solder. Make sure we have a clean hole so we can insert the diodes into. And then put the diode in easily as pie. Actually, no, it took me like 1,200 tries because the legs were bent weird. But we still got them in there eventually. I just add some solder to this end to it. Make sure all that's melted up. Make good contact. Plenty of flux on the board. And there we go. Add some solder here. And then we have one diode right back where it was. This hole looked like it had something in it, but just a little bit of a persuasion from this tweezer managed to clear it out perfectly fine. Then we just got to get this other diode inserted in here. And this was also difficult to get put back in. But we eventually got it. Then, of course, we got to add some more flux. Flux is very, very good. And we just got to solder these back together and hope they don't pop out and fall. And there we go. Just do this other one and done. Now we have to take a look at the other side here. And we got to get this thing all cleaned out for this power cord. And this other one actually did a really good job just pulling it through. And then it removed a lot of the solder. And we just put these in here. I added a little bit of shrink tubing just to make sure there was no connections on the other side. And just heat this up so we have it stuck in place. And we'll snip that off later. Bend it so it's out of the way. Gotta add some flux. Flux is our friend. Then we can come out here and add plenty of solder. Just get this thing stuck down and permanent. Probably could use the bigger iron here, bigger tip on the iron. But it worked out okay. I actually probably added too much solder, but it's still fine. Now we just got to finish up this other one, and we are good to go. Still need to work on my soldering skills, but it's passable. After a few seconds, we are good to go. I will switch back out to the desk and go from there. Okay, here we go. We've done it. We've got all the things soldered back together, and now we get to find out Did we do it? I'm going to add some electrical tape just to make sure that this is okay. Don't want any wires exposed. Wasn't able to get the cable tensioner or whatever it is back on, unfortunately. Now, let's see. Do we have continuity now between positive and positive and negative and negative? Now, let's see. Do we have continuity from this point? Oh, okay. We got continuity from the positive now. Let's try the negative. There we go. Good to go. I think we're making some progress. Now we can put this back together and see if it has voltages that we need. Slide that in there. We'll do that. That should be okay. Now we put this thing back this way. Now let's see if we can fit these screws back on. Okay, that one's done. Let's get this one screwed in. And then there we go. Alright, any magic smoke? Nothing yet. Center pin negative. Reset this up to 20 volts. There we go. And now we just probe this inside pin. And there we go. 13 volts. I guess that's right. Looks like it's working. It's jumping. I don't know why that's jumping around. Should be okay. All right, cool. And red light. Beautiful. I don't know if this is going to work, but we'll try this out. So we got this thing plugged in here and plug this thing into here. This is the Super Nintendo Junior. Okay, if this works, this new setup I got, then we should be seeing some video from the Super Nintendo in 3, 2, 1. It's working! Beautiful. Awesome. So we fixed it. Very nice. Well, we actually were successful. It's funny going down that rabbit hole of trying to figure things out and just was overthinking things. It was just a split cable on the inside internally. So we've saved a Super Nintendo power supply, and now I can go back to recording the video that I started to make first. So, awesome. I hope this was at least halfway entertaining, guys. Thanks for watching, and see you in the next one. God bless.